All right, so continuing this conversation about instantaneous rate of change, let's talk about tangent lines. So the tangent line uh, to a curve y equals f of x at the point x1, f of x, y, f of x1, which is the y, is the line through this point with the slope given by this formula, which looks like what we've been talking about with the average rate of change, but also maybe more accurately looks like the formula with the instantaneous rate of change, since we're taking the limit and this is going to 0. So the tangent line, if you're unfamiliar with this concept, the tangent line is the line that goes through the point on the curve, and it only touches the curve at that point. So the secant line, for instance, goes through at 2 points. So the blue one would be a secant line, and you can see if we want to find the rise over run of the secant line, then we get a plus h and f of a plus h, which would be the point Q, and that difference is a change in y, and then we have a all the way up to a plus h, whatever distance that might be, and that would be our change in x. And so we have this over this would be the average rate of change for the between those 2 points on the curve. And if we shrink that down to now we're only looking at 1 point, and we have a line that only touches the curve at that 1 point, then we call that the tangent line. And so we have the slope of that is the instantaneous rate of change. So those are actually the same things. So let's look at an example here. So find the slope of the tangent line to the curve y equals 2 over x at the point where x equals 4, and then we'll write the equation of that tangent line. And so what we need to do first is find the instantaneous rate of change at x equals 4. So let's do that. And you could do either one. We'll do the first one. So the limit as x approaches 4, and we'll do f of x minus f of 4 over x minus 4. And so let's plug everything in. So the limit as x approaches 4, f of x is 2 over x. F of 4 would be 2 over 4, which is 1/2, and then over x minus 4. So we need to find the common denominator. So the common denominator would be 2x. So this would become 4 over 2x. And we'll just go ahead and write a common denominator. 4 over 2x minus x over 2x. And then all of that's over x minus 4. We can just put that in the same denominator with the 2x. And so now we see 4 minus x and x minus 4, those cancel and leave a -1. So we have -1 over 2x, and now we can plug in the 4 because this is continuous at that point. And that would just be -1 over 2 times 4, which of course gives us -1/8. So this is the slope of the tangent line through that point. So if we look at the graph, I would encourage you, as long as you're getting, while we're getting that concept of this down, maybe look on a graphing calculator or graphing website at these graphs, and you can kind of see what's going on. So if we have 4 out here, we're talking about the slope, and it may not be exactly accurate as far as that's probably not a slope of -1/8, but wherever that would be, it might be further out here where it's flatter, but you can kind of get an idea of what we're talking about when we talk about this tangent line. And you can even, once you get your answer, you could graph the tangent line with the graph of the curve, and you can see how it looks there. So I think that would probably be helpful. It's always a good idea to, especially with the derivatives that we're going to talk about next, to keep in mind the concept. And when we get to chapter 4, especially, that I think that'll be very helpful. So now so that was part A. So let's do part B, where we're going to find the tangent line. So point slope form is the easiest way to write this. I don't think WebAssign is very particular about what form you leave this in. So we'll just do it in point slope form. So we have our slope, and then our point will be 4, and then we can plug 4 in for that, and that would be 1/2. And so really all we need to do, just write out the point slope form, and that is our line. And if you want to convert that to slope intercept form, you can do that as well. Probably on the test, that's probably what we'll need to do. But it is as simple as that, getting the equation of the line once you get the slope. So the slope might be the trickier part, although it's not usually that tricky. And then you can get the line pretty easily from the point. All right. So I think we'll stop this one here. We'll start on derivatives on the next one.